We're now joined with Robert Wagner. He is at Oak Ridge National Laboratory, where he is the Director of Buildings and Transportation Science Division. Welcome, Robert. Thanks for joining us.
Thank you.
So let's start off with, what do you think is the biggest challenge that faces the industry in really the mass adoption of low carbon vehicle?
I think it's just getting the technology out there, whether it's electrification or combination electrification, new fuels. It takes time. And how do we get it? How do we transition infrastructure, turnover of the fleet, all of those things?
And playing off time, history does have a way of repeating itself. And in the early auto design days, we went through a period of diversification in the powertrain and the propulsion options. Do you see that happening when it comes to the business climate for automotive and EV moving forward?
I think it has to, at least during the transition. I don't think we're going to flip a switch and have complete electrification overnight. It's an interesting idea, and technology is certainly going fast, so we'll see. But again, for a while, we're going to have a bit of everything. And some applications, I think, will always, but for a long time, need an engine, especially off-road mobility. So think of rail, marine, aviation's tricky for long distance. On-road commercial vehicles, I think we'll see how the fuel cells, engines, electrification all play out. So it requires a transition.
So do you think when a shift to more sustainable, low carbon mobility will require, development, demonstration, and we have a lot of the companies doing this, but what do you think the role of the national laboratories will be in this in the future?
No, that's a good question, because the national labs they're these interesting big science resources.
Right.
And for example, Oak Ridge National Laboratory is part of the Office of Science. So we have the world's fastest neutron source. We have the world's most fastest computer at the moment. Incredible material science, amazing history. And other labs have similar stories, so I don't want to make this just about Oak Ridge, but there's these neat science tools that a lot of times the sort of foundational frontier type things we find can inspire technology solutions, and often could be equally some technology need, and we turn to the really fundamental science of solid materials is a big one. So I think that's the role they play. These are big facilities that can't be stewarded by anybody but the government.
So when you look at all this, what do you think the critical skills are for the scientists and engineers when you're looking at the future?
I think the big one, and this is something I've always loved about the labs, is working in multidisciplinary environments. So while I certainly have enjoyed a career where I had time to really focus on these fundamental specific problems, it was always with an eye on to how that fits into the bigger picture and trying to understand other disciplines. So I think the students coming up now, this phrase team science gets overused, but it's really important. And you need to understand the disciplines you need to interact with. There's this term I've been hearing recently, transdisciplinary, which basically means somebody is really deep. And say you're really deep in power electronics, but you're also a known expert in high performance computing at the same time. So you have these sort of dual hats where you're very deep and can bring these areas together to solve these problems.
So when you look at all these disciplines and coming together, what do you think will be commonplace in transportation in just, say, a quarter of a century, 25 years from now?
That's another good question. And so I'll think more about some of the technologies, some of the things that have changed in my career, say 30 years since grad school, since undergrad, is things we were doing, like for my research, they thought, well, that's interesting academic curiosity, we'll never see that in production. But now with all the changes in sensors, actuators, data management, onboard computing, I think those things will continue to grow, become more affordable as they've had. We're running computers now that would have been considered supercomputers in the 90s. 25, 30 years from now, will quantum be at a state that we can use it even on board, or if not there, managing really complex systems, if you will, regionally. And so I think we're going to see these things continue to happen. A lot of the technologies in 25 years, we don't even know what they are yet.
Very wise. All right. Thank you so much, Robert Wagner, for taking the time. We appreciate it.
Thank you.